feel like I could go somewhere else.
No.
I feel like my head is dead.
Or two.
Okay, never mind.
Day 2. Okay, I do want to do the first one, a quick little review of what we did on Friday. Grab a calculator if you don't have one handy.
My dad doesn't have one.
Kyle.
I was like, okay.
He runs the tournament.
Yeah, but I got like everyone out.
Okay, real survey that was done. They wanted to know what % of the population actually put something on top of their hot dog as a condiment. So ketchup, mustard, relish, onions, okay. We are going to select 5 people and ask them, do you put a topping on your hot dog? So the question is either yes, I do, success, no, I don't, failure.
So if you don't like toppings, you're a failure.
Yeah.
You should stop trying.
Okay. First thing I would like to do is make the probability distribution. Oh, all right. You want to run and get it, or you just want to? It doesn't matter to me. You don't need it. You just want to take notes on something. Okay, make the probability distribution. That's our table that shows all outcomes and probabilities. So, remember, X is the number of successes. What's the fewest number of successes we can ever have in an experiment? 0. 0 successes. What's the most I can have? In this case, 5, because I'm only doing 5 trials. That's the most. So however many trials you're doing, that's the most you can have. So we are going to have 6 different probabilities in here. And I gave you a by hand formula, but I said we're not going to do anything by hand. We're going to use all the programs built into the calculator. What was the program called?
Binomial PDF.
Binomial PDF. So we just do binom PDF. And normally we feed binom PDF 3 different values. What did we feed it first? N, the number of trials. How many trials are we doing? 5. We're doing talking to 5. Yeah, but it's 6 probabilities, but we're only doing 5 trials. What came next? P, the probability of a success. What is the probability of a success on each trial? 71%. Then what did we put in? X, the number of successes you were looking for. Well, remember when we wanted all of them at once, what was the shortcut?
Just don't put in an X.
Don't put in an X, and it will give you all of them right in order. But if I had just asked for one of these probabilities, like say 3 people out of the 5, exactly 3, then you put a 3 there. So, grab your calculator, those that were not here.
Doing all of them.
Nothing, because we want all of them. Okay, we're gonna go right here. We're going to go to distribution. Second distribution.
Why doesn't my thing scroll up?
Then go down and look for binom PDF.
0.
Binom PDF. It's number 10. Is that what you're saying? Oh yeah, number 10. So 5.
Mine is A.
Well, that's okay. So they're not going to all be the same. 0.71.
That's okay. Okay, so 5 is the trials, right?
Yep, trial.
If there's nothing, you just close it off.
The P is...
Why won't my thing scroll?
I don't know.
We are putting on it.
So that's
So now, the first one represents the probability of getting 0 successes out of 5. And it's a very small probability, and it should be small. So 0.003.
shouldn't it be 0.002 still?
Isn't it?
Oh, it is. I was looking at the 5. I didn't see 002. Thank you. You are correct. And now if we just arrow over 0.025, .123, 0.301, 0.368, 0.180. All right, now I can ask you some probability questions. What's the probability that out of the 5 people you ask, exactly 4 people say yes, I put a topping on my hot dog? So I'm looking for the probability of getting 4 successes out of my 5 trials. 0.368. We did all of them. I just got to read them off the table. Would I have had to make the whole table if that was the only question I asked here? I would have done binomial PDF 5.71, and I would have stuck the 4 in there and gotten that 1 probability only and moved on.
What if it was something like, it has to do probability of 4, like 4 or 5 or something, you wouldn't do that?
Nope, you'd have to do it twice, but I'm going to show you something right now. We're going there. This is what's new today. Now this is new. What's the probability of getting at least 3 of your 5 people to say, yes, I put a topping on my hot dog? What does at least 3 mean to you? 3 or more. So in this case, what would 3 or more mean? 3, 4, or 5. Okay, so I'm looking at the probability of getting 3, or the probability of getting 4, or the probability of getting 5. So what are we going to do with those? Add the 3, 4, and 5 probabilities together. So that would be 0.301 plus 0.368 plus 0.180. Easy enough to do because the table's there. It would have required us to do the binomial PDF 3 different times without the table and add them up. But in a minute, I'm going to show you a shortcut. So what I want to do is put another B here. This is going to be our shortcut. We're going to come back and redo this after I show you something in a minute. So leave a blank line for, it's just 1 line, it'll be a calculator line. I'm going to come back with a shortcut in a minute. Okay, what's the probability that I get no more than 3 people to say they put a topping on their hot dog? So what does the phrase no more than 3 mean to this problem?
1, 2, 3, or 0.
Or 0. So you agree that it's 0, 1, 2, or 3? So we would be adding up those 4 probabilities? Sure. So that would be 0.002 plus 0.025 plus 0.123 plus 0.301. And did anybody do that? Point what?
4, 5.
Did you do it in your head? I don't know if it's right or not. Took Ben in his head answer for that. Okay, that would not be difficult to do. It might take a little bit of time to type the binomial PDF in 4 times or make the table. So we do have a shortcut. That's that binomial PDF. So leave a line for C. We're going to redo C with our shortcut here in a minute. Well, I'm going to come back to these after I show you the shortcut. Maybe I'll just do it over here. I don't care. Well, you can write yours down below, or I'm going to go off to the side here. We're going to use that I'm going to explain to you binomial. Oh, yeah, binomial CDF. C stands for cumulative. What does cumulative mean to you? Total them up. It adds things up. Cumulative. How do you spell cumulative? 1M? Cumulative. It adds up probabilities for us. from, it always starts from x equals 0. And it keeps adding up to and including the x number that you put in here. So it's cumulative. It adds probabilities from x equals 0 up to and including the x value entered. And I'll tell you what that means in a minute. Up to and including the x value entered. So you still have to tell it how many trials you're doing. You still have to tell it the probability of a success. And you still have to give it an x value. And because this is the CDF, it starts adding all probabilities starting from 0 through whatever x number you put in there. So, let's take a look at letter C that we did. We wanted the probabilities for 0, 1, 2, and 3 successes added together. So this one started adding from 0. So I could get the calculator to do this by using B for binomial, and not, we're just going to go CDF. You're going to try this in a minute. We did 5 trials. 0.71 was our success rate on each trial. And what's the last x number that I want included in there? The 3 that I've got here. Go ahead, try that. See if we match that 0.451 that we got. You confident?
Well, I already did it.
I am pretty comfortable with it.
Binom CDF. Make sure you're grabbing the right one. 5, 0.71, 3 we had? 3. So that will add 0, 1, 2, and 3 successes together. Kind of nice.
So how do you do B?
Okay. All right. Good with that one?
Yeah.
What do all of the probabilities in a probability distribution add up to? 1. That was one of the properties of a probability distribution from the first day. Let's go back to B here.
We're going to do 1 minus.
Okay, I want it to give me the sum of 3, 4, and 5. I don't want it to give me these first 3 probabilities. We got 0, 1, and 2. So Dylan, you said what was the plan here?
1 minus BCDF 5.712.
Okay, he's going to go 1 minus the chunk I don't want. So I want it to keep 3, 4, and 5. I want to take off 0, 1, and 2. So I put it in little brackets, so I'm going to take it away. Because this chunk starts from 0. This is the CDF part. I want the leftover part. So because I'm not starting at 0, this is a 1 minus. Binom CDF. So I'm going to subtract off this beginning part that starts at 0. So it's 5 trials, 0.71. And what's the last probability that I wanted to add on and subtract off? This 2 that's in here. Because the part that's in the brackets is the CDF part. So I want a 2 here. If you can wrap your head around this, you're going to get an A in this chapter. Because the next section, the exact same thing, just with 2 different distributions, geometric and Poisson. There's a PDF and a CDF for each one of those. So let's check. Type it right in the calculator. 1 minus. Go get that binom CDF. 5, 0.71, 2. Oh, I never wrote the sum down, for goodness sake. But it does match. I didn't write it here.
If you round it to